Okay?
That's what's really good again.
So we have interesting development here. Our cameraman is
MIA?
is MIA, and so we have a volunteer who's never operated the camera. So thanks for doing that. Grabbed him out in the hall. Hook. So anyway, thanks for doing that. Now, so today is the first big milestone, right? Oh, and by the way, we also have. When do we have our first exam in here?
Thursday.
Our second exam, and that's Thursday. So, yeah, so that's another thing you want to put down on your calendar to make sure you are prepared.
To follow this, are we pretty good?
Oh, actually, that's a good question. On figure 7.50, this is, again, this is the picture, the diagram of the finite state machine that you are implementing for your first milestone. I will tell you that none of this Java code and this will be on the exam.
Darn.
Okay, it will be all the, the exercises and the theory from the book.
Regarding finite state machines?
Oh yeah, there will definitely be finite state machines. Oh, I didn't mean to say, yeah. But I'm just saying I won't ask you details, I won't ask you Java questions and details because that's all implementation stuff.
Okay.
What about the table lookup direct code? So we won't need to know.
Well,
The table lookup?
the table lookup technique, that's coding.
No.
No. The coding that you will have to do is assembly language and know how to translate from C++ to Pep8 assembly language. Pep8 assembly language.
Plus to some similar?
Yeah. We'll go over that tomorrow. How about? Because the exam is until Thursday.
Was that on the last test?
Okay. Yes, it was. And remember, what we've done. What's new this time compared to last time is we've done symbols.
Yeah.
See, we didn't do symbols before. So all that symbol you need, and there will definitely be, if you want to start, studying tonight, there will definitely be another translation exercise. Only the first exam we didn't have symbols yet. But this time you got symbols, and so you need to know how the symbols get translated and how the symbol table works.
It was so long ago.
It was. Yeah. We'll review it tomorrow. Okay. All right. Now, so today, or tonight at midnight, I guess, to be more precise, is when your first milestone is due. And like I said before, I'm going to be really not picky. As you know, I frequently wait, sometimes even days after the assignment's due before I collect it, and you can kind of sneak it in there, but not this time. So just to put you on notice, I plan on collecting them when they're due.
At midnight.
Well, I might.
Tomorrow morning.
Yeah, I probably won't be up. If I'm up at midnight, I might.
Yeah, okay.
But,
You actually are up late.
I am up late. Oh, you've noticed?
You've been here before, and I'm seeing.
Yeah.
11:30?
We
Just
have
in the
late.
office?
Sometimes I come back in.
Sometimes we're having problems with homework at 11. We'll shoot you.
And you shoot me an email and you'll get a reply back. Yeah.
I've never even tried. I should probably do that. I'm always just like, Ashley's probably asleep.
Well, it's not like sending me an email while I'm asleep is going to wake me up. It's not like texting or anything. Anyway, we're a little off topic. Anyway, okay, any questions now? Any last minute questions? I assume that you're 90% done with all your coding and stuff, and how's it going?
I have a question about reading in hexadecimals.
Yes.
If, for example, you have 0x.
Okay, so if you have 0x.
1, 2, 3, 4, 5, 6.
1, 2, 3, 4, 5, 6.
Now, by testing the bounds for hexadecimals, it would stop after, it would become invalid at the 5.
Yes.
Now, at that point, would it consider that a syntax error and then output an integer 6?
It would consider it a syntax error, but do you remember you should design it the same way we designed the sample program. Once you get to a syntax error in a line, boom, you the whole line's done.
Oh, thank goodness, then everything's great. That answers my other question. My other question was if you have, say, an ampersand, and then a space, and then my name, it would do syntax error.
As soon as you get to that ampersand,
It goes to the next one.
yeah, because ampersand is not a valid Pepe
Right.
character on this finite state machine.
Okay. So
I'm-
I'm happy.
I have a question about that though. So like.
About this?
Yes.
Mhm.
So at each stage, we need to check to make sure it's in range.
Yes, you do. Actually, I'm glad you asked that because I didn't explain that very well last time. Here's the problem. Here's why you have to check it each time. Each time you go through the loop, I mean, in the loop is when you check it. The reason is because this could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, and what might happen is it might overflow once and get out of range, but then as you keep adding, it might overflow again and then get back in range, and you would never know it.
Okay. So is it possible?
Do you see what I mean?
Yeah.
So that's, and I didn't, I said, oh, it would just get out of range, but
Because I
see, because the problem is it might get out of range, and then later when it overflows again, actually it would take it doing twice to get back in range.
Because I feel like my code's inefficient. Because if it was a digit, I input it, and then you have to check. And then if it was an alpha, you'd have to put it, and then check. So you'd have to.
Wait. Each time you scan, I mean, whether this is like a D and an F, I mean, what you check is the value after you have multiplied it times 16 and added the value of that thing. So it doesn't matter whether it's a hex character, I mean, whether it's a 3 or a D.
So I could technically do it at the end of my.
You have to do it after you add the value of the character that you just scanned
Right.
to 16 times what you had before.
Right. So that's what. So I have like the if. I have like if, else if to check to see if it was like a digit and then convert it.
Oh, do you have more than one line? Do you have more than one line that does the
Conversion.
conversion?
Yeah, because I have one for alpha and one for a digit. So that's what I'm saying. Do we have to check twice, or is there a more efficient way that we can?
Yeah, it seems like you should be able to do that outside the nested if.
Because I did that,
Can't you do that outside the nested if?
but I had mine as an else if, so I think that.
Oh, but then you had an else. Oh, I see. No, I see. Well, hold on. Let's think about that. Is that really inefficient?
I guess not.
It's not, because you're only going to do one of those.
Okay.
So it's code, all right? You've got more code there, but in terms of efficiency, that test is only going to happen once for each digit.
Okay. Okay.
Now, that was an interesting observation.
Yeah, that's what we were talking
That's
about
interesting.
before. Because we did the same thing for when you're in the first
So,
integer state,
right.
and you could go to the next one,
Mhm.
or like it was when you're in the hex state, because each time you said state gets the next state.
Mhm.
So we're like, do we need to be repeating it every single if statement?
Yeah.
But that's the
Or we
same
could put it
idea.
down. Yeah.
But I mean, if yeah.
It's easier to.
Oh, yeah, hold on. If you can factor out, it's kind of like factoring. If you can factor out a statement that's common in your nested ifs, and you can factor it out and only do it once at the end, if you can do it that way and it's logically equivalent, do it that way. I mean, there's no sense in repeating that code unnecessarily.
Right.
In this particular example, because you have else if, and then an else, you can't factor it out. And so it's okay to have it inside each one of those alternatives, I think.
Okay.
Because it's not affecting the efficiency at all.
Right. Okay. Okay.
These are good questions. It's really important to be able to think like this.
Yeah.
I learned to use refactor.
Oh, you learned to use refactor on NetBeans. Oh, excellent.
Cool.
Can you give us
Let's refactor.
an experience report? I mean, so how do
It's pretty cool.
you, so how do you do how do you do it?
You just go to the top.
You go to the top,
menu
it
bar,
says
and it says
refactor, and then what do you do? Do you already have to have selected the thing you want to rename?
Yeah. Well, all you have to do is kind of have your cursor on it.
Oh, just sort of have your cursor on it, go up there, and rename will be one of the options for refactoring. Yeah, and it'll go throughout your whole project. That's really cool.
So is it okay if our states are just S underscore, or would you want them to be LS?
They really should be LS, because you're going to have another state for, you're going to have a PS for the parser state. So it would really be better.
It was-
But that'll teach you how to use the refactor. Have you used refactor yet? Well, see, that'll be a good way to learn.
The coolest thing is Ashley and I were looking at it, and I just had S_stop, and we decided LS_stop would be better. And there's so many S_stops in the program that I just did the refactor and switched it
Right.
real quick.
Yeah.
So that was cool.
Yeah, it's way cool.
So just go to your state file
and
and,
it's-
do all of them.
Yeah, but it is pretty quick. It's not that
You
bad.
could do S
Very.
underscore.
Because what it does is it goes through all your whole project and does it. See? I'm telling you guys don't know what it was like back in the old days when I had to walk through the snow to school. we didn't have all these neat tools for, you know.
That's pretty cool.
That's true.
So if I've already turned it in before I refactored,
Same here.
I have another.
I just don't turn it in until after.
I can refactor it
Due date.
just so that it doesn't cause us problems later, but do I have to return
You
it
don't
in?
have to enter
Well-
a description for each of the subclasses.
It's up to you.
Ask them yourself.
Okay, any other questions? These are all very minor.
I have 2 questions.
All right.
One was on the UML diagrams.
UML diagram?
For a method that's in the abstract class, we do not have to have that in the UML diagram for the subclasses.
That's right. So, yeah, just make sure it got picked up on the mic. When you do a UML diagram, the superclass, the method in the superclass does not need to be repeated in the subclass, in the UML diagram for the subclass. You can just assume that it's the same, that it will implement that one.
So we don't have to say get description in all of them.
Right.
That's nice.
Then my other question was, whenever you declare what state it's in, or like if you declare that, that it's a token.
Declare.
So like if you've found that
If
it's
you-
an integer, and you say,
Oh, and that's when you do your new, and that's when you
Right.
you knew the token and use the constructor.
right.
Yeah.
So then, how come you can't go back? You have to stop there. You couldn't go to the start again.
What do you mean? I don't understand what you mean. You have to stop there.
You stop once you get the
Because you have to
token.
stop once you get to a token.
Yeah, if you went back to start, then it would try and grab the next character and continue to go down.
But is
That
it
loop.
because-
Oh, yeah. Hold it. That loop here.
It has to do with the main
Let's-
program loop.
Yeah.
Because otherwise it doesn't output all the tokens, right?
Right. Because at the end of every loop, it outputs a token.
Right.
And so the while loop has to restart.
But it restarts at the place where you ended
Right. Or one back. Because that's what
if you
the
do the
backup.
backup unit.
Okay, so actually, does this answer your question in figure 7.31? This is the outer loop. And that's where the token gets printed out. And so remember we said the while loop, the while inBuffer.input remains, that happens once for each line because we got a line. And then inside it happens once for each token. And so when the key thing here is when it says a token gets t.get token, that starts at the start state.
That's tokenizer.job.
That T is the tokenizer, and get token is the one that does all the work. And and at the beginning of get token, that's where it initializes. Let's do get token here. On this figure, the very first thing it does is, look what right there, it says state gets S start.
Okay.
So that's
Okay.
each time you call that tokenizer for the next token, that's
Then
where
it
it gets reset to
Whereas
start.
it made more sense to me because I knew that it had to go back.
You had it, yeah, but no. You shouldn't. No, in fact, you shouldn't.
Well, I mean,
Because the state needs to be stopped to get you out of the loop.
yeah,
The tokenizer loop.
right. But I guess I missed that last line. 'Cause
Yeah,
then I
well,
was confused
there.
if I was starting at the
I see.
stopped.
But there it is. Yeah.
It's initials.
Yeah. See, and this is really a global. Yeah. When you have a program that's this complicated, a project, a software project that's this that's going to be this big, you really have to have a really clear idea of what the top level, the most abstract, the top level outer loop is. You really have to have that well in your mind, because otherwise if you start doing stuff like that, if you start saying, oh wait, do I have to start here? You have to, in your mind, you have to make sure you design your initializations all at the appropriate places. And you can see here, well not here, you can see in the previous one, in the main program, you can see here is the top level, it's the top level of the loop that drives the whole thing. Now, of course, what's going to happen is this loop is going to change next time around. I mean, because this is just a code for the main program of in this milestone is going to be done away with. All right. So this is called a driver. This main program here is called a driver. So what's going to happen, because what will happen is the code that, the tokenizer code and the buffer, those will all stay the same. And this driver code is just used to exercise the code that will remain in the project. Do you see what I mean? That's called, in software testing terminology, that's called a driver.
Is that at all related to drivers that we use for hardware?
No, that's hardware. This is software. But drivers, we're taking a little bit of a bottom-up approach here. By the way, I have gone through so many iterations of this project, top-down, bottom-up and stuff, and I have found what you are experiencing. I think one of the reasons this is going to go pretty smoothly is that you are experiencing the end result of a lot of working through this project a lot of times. And the main thing that this is a bottom-up test. In other words, you're actually doing the lowest level of abstraction first. The other way to do it was we could have started with a parser.
Oh.
You see what I'm saying? What if I had let's think about that for a minute. What if you had written the parser first?
It'd be confusing.
I like this way better.
Well, I mean, there are some people advocate. I mean, there,
So we would be
that's going top down. That's going at the highest level of abstraction down. And some of it, I mean, sometimes you have to start at a top level. Sometimes it's better to start at a top level, and we could be doing, but in that case, what would happen is when the parser would call the tokenizer, but we wouldn't have written the tokenizer yet. So then what you have to do is, instead of having a driver, the code that you have for calling the tokenizer is called a stub. And all you would do is you would just always return the same token. And that would be a stub. And then you would test the top one first. And then later, after you get that all debugged, then you would debug the ones at the lower levels of abstraction. See, but now this is really important software engineering stuff. I mean, you understand can you see the issues that would be raised doing a top-down versus a bottom-up? Right. So just to note that, I think it's really important to note that this is a bottom-up because we're starting with the buffer, and the tokenizer. And so, but what that means is that this code is going to be different. We're going to throw this code away in this main program code. But your specification, the tokenizer, it's easy to specify exactly what that tokenizer does. And so that's how we're doing it. Are we good? Any more questions? All right. Well, this is really excellent. Now, the next thing we are going to do is we are going to start the next part of the project will be the parser. Now, to use the parser, or to write the parser, we are going to have to do some table lookup. So you remember what we said, like if we said load accumulator, I don't know, like 0x51b7, comma, s, stack relative. Is there an SF?
I think so.
SF, stack relative deferred. Okay? So, and remember what we said is we were going to, what we would do is we're not going to have a transition on L and another transition on D and another transition on A. Instead, this whole thing is just going to be, an identifier token. And then what we have to do is, what the parser is going to have to do is it's going to have a table with all the possible mnemonics stored in it. And then it's going to have to do a table lookup to make sure that this is one of the ones that got, that this is a valid mnemonic for an instruction. So the question is, how do you do table lookups in Java? And to answer that question, we're going to do a demo. So check this out, sports fans. Okay, so here's our demo, and it's called Map Demo. And I think I'm just going to run it because, as I recall, yes, Map Demo is the main project. So watch this, you guys. Are you ready for this? Ah! What does this dialog box say? Enter a planet. Give me a planet.
Jupiter.
Jupiter. Is that how you spell Jupiter?
Yeah.
Now watch what happens when we press enter. Jupiter is a big planet. And what else does it say? Now check out what else it says. Enumerated output P underscore Jupiter. And what else does it say? Ordinal output 4.
Is it the fourth planet? No, Mars.
Well, I mean, that's the ordinal, well, starting at what? I mean, when we do ordinal values, they normally start at 0. What's the one closest?
Mercury.
That's gonna be 0.
Let's do Mercury. You don't know those planets?
It's
Oh, I don't know.
M-E-R.
Very eager mother just served us 9 pizzas.
Pizzas? Really? 9 what?
Pizzas.
9 nothing.
Is this how you spell Mercury?
Yeah.
Mercury is close to the sun. Enumerated output, P Mercury, ordinal output 0. Now, check this out, you guys. What would happen if we did this? What would happen if we
It
did
does not exist.
Planet Ash.
Mercury? What do you suppose would happen if we did that?
It's fine.
It's the same.
Mercury is close to the sun. Are you with me? But what happens if we do something like this?
It'd be so cool if there was spell check.
It won't.
Not a planet.
Yeah, Texas is not a planet. All right? Now,
Try Pluto.
oh, try Pluto. You know they say Pluto's not a planet.
I know.
That's ridiculous.
That's why I'm testing your program.
All right, according to this
It
program, drum roll. Yeah,
I did know.
we have not expunged Pluto from our solar
And
system.
that's why I'm a computer science major.
All right, is everybody good?
I love Pluto.
But, and even if we make this uppercase O,
Pluto is fine.
Pluto. Oops, I tapped it one more time.
Still a planet?
That's the one that I do. How
What about
close it
Saturn?
was. I knew
What does it
that
say
was-
about
Saturn, what does it say about Saturn?
It's ordinal number 5.
Oh, it's also a big planet.
What about Earth?
Oh, Earth is a planet. Try it. I'll do lowercase e, but watch what it does. The Earth is indeed a planet. Ordinal output 2. Okay, so that's our demo. That concludes our demo. Okay, so that's our demo. And here's a little screenshot that just shows what we just got through doing. And one of the things that we noticed in the demo was that those planets were enumerated. Okay, and we've already know how to do enumerateds in Java, right? So here what we have is our file planet.java, and we have public enum planet, and we have them all listed there, P for planet. Okay? Is everybody clear on that? And do you see that the order that they're listed here in the in this set of, well, it's actually not a set because the order doesn't matter. This is more like a list. But Mercury is 0, Venus is 1, Earth is 2, and so on. Is everybody clear on that? So that's in its own file. And now, you guys, comes the map. So now this is a model now of how you're going to set up your maps for looking up these, these kinds of things. Because basically, what do we enter when we enter, in that box? What type are we entering in that box? A string, a Java string. So whenever we, in the main program, whenever we get that, what we're getting is a type string, class string. Okay, and so let's take a look at, there are actually two maps. And this, first we want to notice that we are going to store our maps. The maps are going to be stored in their own file. Okay, so this is not in the main program at all. So this is in file maps.java. Is everybody good? And what we're going to, and then there's some imports that you can just copy and paste. And we're actually going to have two maps. This program is going to use two maps, which will correspond to what you use also. The first thing that we have to do is, when we look up a string, we get the string from the dialog box, right? What we need is a map to convert the string to an enum. Are you with me? Is everybody clear on that?
Okay.
A map is just it's a table lookup. All right. So the first map will convert a string to an enum, and that's the one that's called planet table. So you see, it's public static map, and then the parameters for map, they look kind of like what is that called in C++? With the angle brackets? Oh, come on. How many times? We did that, huh?
No.
Oh, matrices.
No, matrices are square brackets.
Oh, that's right.
We did it.
Oh, you did it so many times. How many times have we done? Oh my goodness.
Yes.
With all the
it's that.
trees.
Yeah, with all the T's.
Yeah, what would you usually put in there? A type, right?
Like an.
What is the facility called in C++? Yeah,
Okay.
it's a template. Yeah, this is just like a template in C++, right?
But I wanted to say.
And furthermore, we have these are classes. I mean, they're like types, right? Okay, so look. So this first map. So the first one is the key. The first one is what you're looking up. Sorry, the first one. What are the two types in planet table? The first one is a string, and the second one is a planet. So the idea here is that what you do is you're going to look up. You're going to give it a string, and it's going to give you the planet, the enum. Do you see what I'm saying? You're going to give it the string, it's going to give you the planet. So that the first parameter in map is the one that is the one that you're giving it, and the second one is the one that it gives you. Are you with me? So the first one is kind of like the key. Remember how we had key value pairs?
Dictionary.
Yeah, that's what this is.
Yeah.
This is a dictionary. Yeah, this is what we call dictionary. So it's a key value pair. Right. Oh, I'm glad you said that. Okay, so we give it a string, it gives us a planet, and a planet is an enum. Are you with me? So that's planet table. But now, do you remember after we entered the planet and clicked the button, it had to look up, like when we put Texas in there, it tried to look it up. Texas was not a planet, so it just said it's not a planet. But if we put like Earth in there, what did it do?
Return.
It said Earth is indeed a planet. So now, and how did it spell Earth? Capital E, lowercase E-R-T-H, right?
Oh, even though we put.
Even though we put, right? So what we want is we want to have a standard canonical way to output the enumerated value. I mean the enumeration. You see what I mean? So that's going to be our planet string table. So planet string table means now it's just reversed. We're giving it a what? An enum, yeah, a planet which is an enum. And it gives us the what? The string in the way that we want it to have displayed, the way that we want to have it, so that uppercase, lowercase won't.
Both maps are executed every time.
A map, hold on. A map is not a A map is not executed.
Right.
A map is a data structure, it's not a method.
Okay. But what I mean.
Are you with me? So it has methods that enable you to.
Both maps, the methods of both maps are used.
In this program, yes.
Every time.
In this program, they are because, well, I take it back. When we typed in Texas, the planet string table was never used.
Then how did we get a string that said it was not a planet?
It was, we echoed the string that was input by the user.
Okay.
So if you
Because Texas is not one of the ones that are in there.
Right.
So if it's not,
Are you with me?
if
Are
it's
you,
not
we,
planet, then it cut and pastes whatever.
it,
we-
So if you would
yes.
have written it in all caps, it would have appeared in all caps.
It would have appeared in all caps.
Okay.
Oh, that was, yeah, that's a good way to explain it. Okay, is everybody clear on that? Now, what does static mean?
Always.
One per class,
Instead of?
object.
one per object.
Yes, one per class instead of one per object. So these maps exist, there's one of them, and they get set up, because they're static, then they get set up once, and then they stay there. All right? Now, and so the way we set it up, we say static, and then all of these statements happen once at the beginning when the class is used. I mean, once at the very beginning. These are the initialization statements that happen once to get everything all set up the way we want it. Actually, what we have to do is we have to populate both of these maps. Are you with me? So what the first one does is, so first we'll do planet table. So we do planet table, and that's a static statement, executes once at the beginning. So planet table gets new now. What these are is we're going to use, it's a hash map. So a hash map is a particular kind of map in Java, and you can look up well, actually we did hash tables, right? So you know how hash tables work.
Yeah.
And here again, it's key value pair. All right. So so it's new hash map and then string planet. Are you with me? So that planet table has to be the same planet table that you declared up there to be public static map. Okay. And so a hash map is a subclass of map. Are you with me? So that's a particular one. Yeah, the dynamic type. And look at what we're doing. Look at how we are populating this map. We're populating it with the string value is what? All what? All what case?
Lowercase.
It's all lowercase. The string values are just going to be, we're just going to make them. Now you could do it either way. You could either do them all lowercase or all uppercase. Okay? And you'll see the code in the code what happens. What we'll do is when we grab the identifier from the text box that the user put, we're going to, before we look it up, we'll switch it to lower. So no matter what case the user does, because we know that because we're populating it with the lowercase versions of the string, right? So Mercury, planet dot p underscore Mercury, etc., etc. Is everybody clear on that? Is that easy? And then look, here's the other one. New enum. Oh, this time now. Why is this one? Why do you suppose this one is a hash map? This planet table. This is a hash map, whereas this next one is not a hash map. What is it? It's an enum map. Now, why do you suppose this one is an enum map, whereas the other one was a hash map?
Because it takes enumerate.
It takes enumerated as the key. So there's no hashing involved here. Right? Because remember, when we did our hash tables, we hashed strings, actually. Remember how we did that? And so it has built into it that hashing ability, but that's what's appropriate whenever the key is a string. Is everybody good? And so this is see how great all this data structure stuff is? You understand how all that stuff works, and now you can just see it right here. It's provided for you by the library. You don't have to write your own hash. Fortunately, you don't have to write your own hash table, but you know what some Java library programmer had to do. You understand what he had to do because, and look, it's the same thing. Oh, put. Did we notice here? The method is called put, right? So similarly with this enum map, the method is called put. Only this time we put the enum first, and notice that the string, which is the second parameter, is the way we want it to appear in the output. Are we good? Okay? And now here comes blah, 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 blah. This is the main program that does, you know, the same stuff that we know and love. And here's blah, blah, blah. Lay out the label and text field input panel from top to bottom. Here's the code that just does all that kind of stuff. More stuff. And here is create and show GUI. And then finally, action performed. All right, now what happened whenever we clicked the button or pressed return when the cursor was in that text field? It, you know, sent stuff out to the console, right? And so the first thing that we do is we have a local variable line, type string, text field.getText. And now check out the very first if statement. If what? Now maps, so what was maps? Yeah, that was the class, right? Okay. And then what tables did it have in it as attributes?
String table.
Yeah, it had those attributes, right? Those are the attributes of the maps class, right? And so if maps dot planet table dot and now
Key value.
yeah, if maps dot planet table dot what's the name of the method? Contains key. Line dot what? To lowercase. So no matter what case the user typed in, we convert that line to all lowercase, and there is a method in planet table named contains key. And that's how you guard the access to make sure that it's in there. After you've guarded, after it passes that guard, now if it's not in there, what do we do? Let's skip down here to the next slide. If it's not in there, else what do we do? System.println, and what are we saying? Line is not a planet. And line is that original line that the user typed in. Are you with me?
So it doesn't, when two lowercase does not change line.
Two lowercase changed uppercase T Texas to all lowercase T Texas, but lowercase T Texas was not in there.
Right.
It was not contained. But notice that it did not change line.
That's what I was saying.
Yeah. It returned. What it did is it took line and line dot to lowercase returned that lowercase, but that doesn't change line.
Okay,
It's a function, not a void.
Right.
It's not mute. Actually, it's a string. What do we know about Java strings?
They're immutable.
They're immutable. As opposed to what?
Mutable.
Mutable, which is what Java type?
String buffer.
String buffer. Is everybody good?
We're learning here.
So at this point, after we pass that guard, now we know it's in there, right? So now what do we have? We have a little local variable called what? Planet, of type capital P planet. So it's an enum. Are you with me? And we do gets what? Now maps dot what? Planet table. So now what are we?
We're looking at that table.
We're giving it the same thing, but now we know that it's in there because we guarded it. Yeah. And so now we know so planet gets maps.planet, and then planet string gets, now what is our planet string going to be? Maps dot what? Planet string table dot get the planet. Okay, so now the planet, we got the enum. From the enum we can get how we want to print it out. Are you with me? And now what do we switch on? The what? What type? On the enum. We switch on the enum, just like we switch on our state enum, our enum states. In this one we're switching on this enum, and we lumped. Did we do Mercury and Venus?
We just did Mercury.
We didn't do Venus.
Jupiter and Saturn. They both said.
We did do both Jupiter and Saturn. So there's case P Jupiter, case P Saturn, and then we said system.out.println. And then, printf. Okay, so let's look at Jupiter and Saturn. System.out.printf, and then now what are we printing? %s. So that's the string. And then what are we printing? The planet string that we looked up.
So if you don't
That's
have
it.
a break, it just goes and does whatever's in the next.
No, there is a break.
That's what, after Jupiter. Like the Jupiter, it gets whatever.
Oh, yeah. Look, what'll happen is if it's case P Jupiter, because there's no break, it will just fall through to the next one.
Okay. That's cool. Okay.
This is just like C and C++. Actually, this is the way. Well, I don't think we ever had a situation where we wanted,
we've never done
where we've never had. Yeah, well, this is good. Actually, I did it this way to show that this is a how you do multiple cases, huh?
Unless you forget your break and then you do that.
If you don't break it, then
If you don't break it, it falls through to the next one. And so what happens is if it's Jupiter, it just falls. It's because there's no break, it just falls through and does. And it does the same thing that case Saturn does. Does everybody see how that works?
what if there's no break and you implement both of them?
It will fall through.
So it'll do the one.
It will do the one and it will fall through and actually do the other one. I have actually seen code on purpose designed that way. But it's very, very rare.
Right.
It's usually a mistake.
So you'd have to have a case where you want it to do
You'd have to have a case and do the exact following case.
Yeah.
So,
Cool though.
but you can, I mean, it does have that flexibility if you ever need to do that. And then that's basically it. Okay, here's the case for Uranus, Neptune, and Pluto. Those three are far from the sun. So, and then system.out.printf. Oh, and then actually after it has done those cases, right, so there's the end of the brace of the case, now what do we print? Oh, actually this is interesting because it shows you how to print the enumerated output. Do you see how to print the enumerated output?
Mm-hmm.
It is a string, but what do you give it?
And then
Planet.
You give it the enum. And Java knows how to print out the identifier for that enum.
cool.
So you don't, it doesn't require a special,
String.
yeah. This is called, this is an example of introspection, where the programming language gives you the ability to access the identifier in the program. Do you see what I mean? That's called, in programming language design, that's called introspection. And then, but now it does require a method. How do we get the ordinal value? It does require this method named what?
Output or
Ordinal. Ordinal. Okay? And that's an integer. So we use the %d. Now you guys are going to have to need, you guys are going to need this when you do your code generation. You're going to, I know what's going to happen. I'm going to say, now you remember how to do the ordinal? I say, no, we never did ordinal. So anyway, then we'll have to come back here and remember. Okay? Is everybody good? Mm-hmm. All right. Excellente. See you tomorrow. Thanks for the video assistance there.